Okay. Okay, so notes 8 is going to be over the difference of squares and perfect squared trinomials. So recall in note 7, we talked about how to factor a trinomial where we did two numbers that multiply to that AC value and then another number that added to the B value. So we were trying to find that combination that satisfied those. These ones are more special cases. So the first special case would be factoring a difference of squares. So notice in the example, we have a squared minus b squared is equal to a plus b times a minus b. So the big thing here is notice the signs are different. The reason the signs are different is because when we FOIL this together, okay, what's going to happen is that those middle terms are going to cancel. So that's why we're only left with the first term squared and then the last term squared. And you'll know that you're able to use factoring by the difference of squares if they are perfect squares. So for example, 25 is a perfect square because the square root is 5. 36 is another perfect square because the square root is 6, and so on and so forth. And I have all these examples here of what it looks like to be perfect squares. So not only does this have the numerical values, but also the x values. So x squared is an example of a perfect square because this is the same as saying x times x. Okay. Same with, for example, x to the 8th. X to the 8th is a perfect square because that's the same as saying x to the 4th times x to the 4th, or x to the 4th squared. Okay. So it will make more sense when we're looking at the examples. So for example, in this one, remember our standard form here is a squared minus b squared. Which means instead of labeling A, B, and C like last time, we're now just labeling A and B. So that first term minus the second term. So here, our A squared value is going to be equal to Y squared. Okay. And our B squared value is going to be equal to 25. Okay. So when we are looking at this, we know the end goal is to have two parentheses where one is plus and the other is minus. And what's going to end up going here is our two A values and then our two B values. Well, in order to find A and B, since we have A squared and B squared, we're just going to take the square root. So here, A is going to be equal to the square root of y squared. And who can tell me what happens with the square root in the square? They do what? Cancel. Okay, they cancel each other out. The reason for that is one is squared, which means we multiply it by itself, and the other is the square root. These things will always cancel each other out. So I'll write that here. This will cancel. Okay. So that means our A value is actually just y. So I'm going to go back here, and anywhere I had an A, I'm going to put a y. Okay, it kind of brings it back to when we were doing factoring on the last notes, and someone asks, well, how did we get x squared, or where did the x squared go? Well, we put it into two different factors, so if we FOILed that together, they would come back as a square. Well, we'll do the same thing with b. So in order to get b, we're going to take the square root, so the square root of 25 gives us 5. So then I'm going to write a 5 here. Okay, which means my answer is y plus 5 times y minus 5. Okay, and then I can check my work by taking these two factors and FOILing them together, so multiplying them in. And what I should end up with is my x squared minus 25. So I would first do y times y, which is y squared, and then y times negative 5, which would give me y times negative 5. Negative 5y. Good. Then I would do now the 5 into the next parenthesis. So 5 times y gives me 5y. Okay. And then 5 times negative 5. Negative 25. So then if I look here, I have y squared minus 5y plus 5y minus 25. What's going to happen to these two middle terms? They cancel out, because if we take negative 5 plus 5, that's 0. It cancels. So these are gone, which means I'm left with my original equation, y squared minus 25. Remember, this step that I'm doing here is just me checking my work. This is not part of the problem. My answer is what I got up here, the y plus 5 times y minus 5. And then, of course, in the first couple, I'm going to break it down step by step, but hopefully as we keep going, you notice that the a and the b are going to be perfect squares. So technically what we're doing is we're taking the square root of each of the terms and then writing that into two factors. Okay. Okay, so then now we have 49s squared minus 4t to the fourth. Okay, so I'm going to do the same thing. I'm going to label what my a squared and my b squared are. So a squared is going to be equal to 49s squared. So a squared is the first term. Okay. B squared is my second term. So b squared is 4t to the fourth. Yes. The negative in this case is going to stay there, because that negative, what it's telling us is it will kind of, because it's going to give us two parentheses, one with plus, one with minus. That's all that minus is telling us to do.
As opposed to 2 with plus.
Correct. Another reason why we wouldn't carry the negative is, can you take the square root of a negative number? No, so it would mess up our process here if we did that. Okay. So let's look at a squared first. In order to get just a, we have to take the square root. So we're going to take the square root of 49s squared, which would be
7.
Good, 7 for 49, and then the square root of s squared will just be left with s. So that means I have 7s first. Okay, then I do the same for b squared. In order to find b, I take the square root of 4t to the fourth, which gives me
2t squared.
2t squared. And again, I know this is going to be t squared or s based off of this table up here. Remember, you have your notebook during the exam. So if you're not sure on where they're coming from, just find it on here. Okay, and this is where we're able to say, okay, x to the fourth, if I take the square root, is just x squared. Okay, and of course, the x's are the same as saying s or t. Okay. And so on the other part, I'm going to have 2t squared for each one. So this would be my answer. 7s plus 2t squared times 7s minus 2t squared. Okay. Eventually, you should be able to do this step in your head. Okay. But if it helps, of course, write down every single step. Okay. Okay. So then we have something that looks like this. Okay, so before we go ahead and do what we were doing in the previous two questions, you should be thinking to yourself, okay, I have 18 and I have 2. Are these perfect squares? No. So that tells me maybe I can take out a GCF first. So what could I take out that they both have in common? A 2? Anything else? A z. Okay, so if I take out a 2z, and then I divide each part. So I have 18 divided by 2. 9. And then the w squared can just come down. Okay, and if I take out the z, these two z's are gone. So that first term, I just have 9w squared left. What do I have left in my second term? Minus 1, right? Because if I take out a 2z, this 2 is now gone and the z is now gone, which means in its place is just a 1. Okay. So now that I took out that GCF, I'm just going to pay attention to what's inside this parenthesis and see if I can factor them by perfect squares. So then before you continue, you think, okay, can I take the square root of 9? Yes. Can I take the square root of 1?
No.
Oh, go ahead and try it on your calculator. Can you take the square root of 1?
Yes.
Yes. What is the square root of 1? 1. So that means I can go ahead and start saying, okay, this is my a squared. So a squared is equal to 9w squared. And this is my b squared. B squared is equal to 1. Okay. And then I take the square root of each one to find just a and b. Oops. Okay. So that means for this one, I would take the square root of 9w squared, which would give me 3w. And this one, I would take the square root of 1, which is 1. So when I write my parentheses, so I'm bringing down my GCF. That's going to come with me. And then when I do my parentheses, I know one is going to be plus and the other is going to be minus. And what would my first parenthesis look like? 3w plus 1. And then what's my second parenthesis? 3w minus 1. This whole thing is my answer. So if you go and you see a question that doesn't look like they have perfect squares, your first step is to see if you can take out a what? GCF. Any questions so far? Okay. Go ahead and try this one. So take a minute or so. Complete this one and then compare with your neighbor. Okay, so the first thing you should have done was identify your a squared and your b squared. I know I can do this because just by taking a glance at this, I know 25 and 49 I'm able to take the square root of. Okay, so now that I labeled a squared and b squared, what did you guys get for a?
5Q.
5q, because we take the square root of 25q squared. Good. And what about for b? 7w. Good, we got that by taking the square root there. So that means my two parentheses, what would my first parenthesis be?
5Q
Plus 7w. And the second one?
5Q minus 7W.
Good, perfect. Does it matter if you did minus first, then plus? No, as long as one of each is there. 1 plus, 1 minus. The order doesn't matter. Okay. Okay, now we're going to look at something a little different. So it says, suppose a and b have no common factors. Then the sum of squares, a squared plus b squared, is not factorable over the real numbers. That is, a squared plus b squared is prime. Okay, so the big thing here is if you're looking at an example like this, what is different here than the previous ones?
Plus.
It has that plus. Okay, if you see that plus sign, that tells you automatically, even though p squared and 9, you can take the square root of each, this tells you that this is prime. Okay, if you see that, automatically you write prime, that's your answer. Okay, again, the reason for that is that there's no way to get a positive 9 without having any middle terms. Okay, so let's say you make the mistake. This is what if, right? What if you did this? Okay, let's say you made the mistake and you saw this, you forgot about the plus sign, minus sign, and you said, well, I know this has to be me taking the square root of p squared and then the square root of 9. And then you did this. Well, this has to be p plus 3, p minus 3. Okay? If you were to check this by foiling, okay, what you'll notice, and I'm going to show you two mistakes that commonly happen here. What you notice is that, okay, let's FOIL this out. So p times p is p squared. P times negative 3 is negative 3p. Then I multiply the next part. 3 times p is positive 3p. 3 times negative 3 is negative 9. Okay. The middle terms, because one's positive and one is negative, is going to cancel out. Negative 3 and the positive 3. So I'm left with p squared minus 9. So first you're seeing this and saying, okay, well that doesn't match because our original one is positive and this one is negative. Well, let's say you think, well, that's okay. If in order to make that positive, I'm just going to make both of these positive. Okay, so let's see what happens if we do that. Okay, you make both of these positive. We're still going to FOIL out and see what's going to happen. So first part, so p times p is p squared. Okay, p times 3 is 3p. And then we do the bottom. 3 times p is 3p. 3 times 3 is 9. What happens to our middle terms here? 6p. So this is p squared plus 6p plus 9, which almost looks like this. But our original equation did not have this middle term. Okay, so that is the reason why we say it's prime. Okay, again, if you want to write these down, I would say these are like common mistakes.
So just automatically call it prime.
Automatically call it prime. That's all you have to do. Prime is the answer. And we know that because of that plus sign. Okay. Another reason I know that is if I look at this, can I take out a GCF? No. So there's absolutely nothing I can do to try to simplify this. So automatically it's prime. Okay. So if you see, for example, this one, you know that the answer is prime. Okay, because of that plus sign. And that's all you have to write, prime. You don't have to show me any work or any proof. Okay. And again, we know that these were prime because there is no such thing as a sum of squares, and that's what this is showing you here. But when we did this in the beginning, this was a difference of squares. Okay. There's difference of squares, no such thing as sum of squares. Okay. Okay. Now we move on to these type of examples where, yes, we can factor them because we have difference of squares, but maybe after you factor it once, you may have to factor it twice, okay? And we'll see that here. So if we do the same steps we were doing, we would say that a squared is equal to what? W to the fourth, and b squared is equal 81. So then we take the square root of each of them to find our a and b values. So what would a be? W squared, good. And what would b? 9. So then I write my parentheses out. I know that my first parenthesis will look like W squared plus 9. And then my next one has to be W squared minus 9. Okay, so you might think, okay, I did it, I factored it. But here, you're going to now have to look at each of your factors and ask yourself, can I do this one more time? Yes. So looking at this one, could I do this one more time? Yes. This one that I circled?
No.
No, that one's prime, right? This one's prime. So I can't simplify that further. Okay, but what about this one? Yes, so if I'm doing this one I would say a squared is equal to W squared, and b squared is equal to 9. And then I take the square root of each, which means that a is equal W and b is equal to 3. So that means from this one, I'm able to break it down even further into the two parentheses that will say W plus 3 and W minus 3. What do you think we do with this one? Does it just disappear? We bring it down. So W squared plus 9, which means this entire thing is my answer. Okay, just because this is prime doesn't mean it can't come with us. Think of it like the GCF. Okay, we couldn't do anything more with the GCF, but we still have to bring it down. It's still our bestie, right? We have to bring it with us. Okay, it just couldn't be simplified any further. Okay.
So if you were to check, to be sure, you would have to do FOIL with all.
Yes, that's a great question. I'll do that for this one. So the question is, okay, how do we check this? Okay, because there's 3 parentheses this time. So how you would check this is you have to take 2 of these parentheses and FOIL them first, then FOIL the 3rd parentheses. So let's go ahead and do that with the first 2. So we have W squared plus 9 times W plus 3. So I'm going to FOIL these together. So that's W squared times W, which is W to what power? Cubed. And then W squared times 3. Not yet. W squared times 3. Yep, 3W squared. And then we do 9 times W And then 9 times 3, 27. Okay, then I look at this. Can I combine any like terms? Do I have more cubes or more squares or more single W's that I can combine together? No. So then I'm going to take this, make it our parenthesis, and I'm going to bring down the W minus 3 because that's the last one I need to FOIL together. Notice though, I'm not only FOILing binomials, meaning 2 terms. That first one had how many terms? 4. So when I FOIL these, it's going to be a little longer of a process. I'm first going to do, and let me move this down. So it's going to be, oh, okay, there we go. So I can put my arrows up there. Okay. Okay, so I'm going to do W cubed times W, and then W cubed times negative 3. So that's W to the 4th minus 3W cubed. That's the first red arrow. Then I'm going to do the same with 3W squared to W and negative 3. So then I get 3W squared times W, which is 3W cubed. 3W squared times negative 3 is negative 9W squared. Okay. Then I have to do the same with the 9W. So this is plus 9W squared minus 27W. And then I'll do the last thing with the 27. So 27 times W and 27 times negative 3. So that's plus 27W minus 81. Okay. So then we go through and we see if we can cancel anything. Good, because this is negative 3W cubed, positive 3W cubed. Negative 9W squared, positive 9W squared. Negative 27W plus 27W, which means we have W to the 4th minus 81, which is our original equation. So it is still possible to check your work. It's just going to take a little longer, right? Because especially if you have 3 parentheses, you're going to have to FOIL twice. Okay.
So I guess like
Yes.
a good way of thinking this is you said we're not always going to be going down to doing this right like this big equation where there's a prime on the left side and then the right side is still factorable.
Yes.
Is it just always taking into consideration if everything is at its most simplified form?
Yes. But it could be also, we could also get to a point where maybe this wasn't prime and we could factor that one further.
Okay.
So it could possibly, not saying always, but it could possibly be where this also could be factored. And then it also could be we take a GCF from the very beginning. So when we do all that, when we get down to this part where we no longer can simplify further, this is as simplified as it's going to get.
Yes.
Okay. Let's look at this one. Okay, so for this example, we have y to the 4th minus 1, which means a squared is going to equal y to the 4th, and b squared 1. So then we take the square root of both, so a is equal y squared, and b is equal 1. Okay, so what would my first parenthesis look like? Y squared plus 1, and then my next one? Y squared minus 1. Okay, then I look at each of these, and I ask myself, can I continue? Good, the first one is prime, and I know it's prime. Why? Because of this plus right here, so it's prime. So So that means I can't do anything further with this, so I'm going to look at the next one. Can I continue this one? Yes. So then I do the same thing, okay? A squared is equal to y squared, and b squared is equal to 1. So that means a is equal y, and b is equal 1, right? Because we took the square root of each of these. So that means bringing down from this one to simplify further, I have y plus 1 and y minus 1. And then what happens to that first prime parenthesis? It bring it down with the rest. And that's our answer. Okay. And then also as we get further along, when we start learning about all the different types of factors, there might be instances where they are all mixed together, where we do a normal factor by grouping like we did on the last notes. And then after we do factor by grouping, you may end up with something like this, that you would have to use the difference of squares to factor more. Yes?
I have a question.
Mm-hmm.
On the example 49s squared minus 4b squared.
Mm-hmm.
Our answer was 7s plus 2g squared.
Yes.
Why aren't we factoring the 7s minus
This one?
2g squared? Yes, ma'am.
Okay, so then you look at, before we try to do this, yes, it has a minus, but look at the numbers. Can you take the square root of 7?
No.
No. Can you take the square root of 2?
No.
No, so it's not factorable anymore.
It's just by the number.
Yes, it's by the number. So the reason why we're able to do the other ones is if you look at each of the numbers, they're able to take the square root of them. So if we go back to the one we just did,
4 squared.
yep, we were able to take, ignoring that one, looking at the y squared and the 1, we know that the square root of y squared is y, and the square root of 1 is 1. So we're able to continue because we're able to take the square root.
Okay. Okay.
Okay, so now you end up with something like this. Okay, so we have 4 terms here. And anytime you see 4 terms, you should think of what? Factor by grouping. Which means our first step is to put them in parentheses. Factor by grouping. That is every single time you have 4 terms. Okay? This is where I was talking about before, where we can end up mixing together all our different factoring methods into one. So if I was to do factor by grouping, that means I need to take a GCF out of each parenthesis. So looking at the first parenthesis, what GCF can I take out? Y squared. Good, because they have more than one y together. So if I do y squared and I take that out, what's left over? From the very first one. Good, y minus 5. Okay, and then I want to end up with y minus 5. So I know the GCF that comes out of the next one is going to be minus 4, right? Because I want a positive y there. So when I take out a negative 4, I'm left with y minus 5. Okay. Once I get to this part, factor by grouping, what's my next step?
We
Bring down y minus 5. Good, and I bring down everything that's on the outside. So y squared minus 4. So I just factored this by factor by grouping, but I still need to look at each of my parentheses and ask myself, can I continue further? So looking at this one, can I continue?
No.
No. Y minus 5, I can't, right? But what about this one?
Yes.
Yes, and I know that because I can take the square root of y squared and I can take the square root of 4. So then from here I know a squared is equal to y squared. Okay, which means a is equal to y. And then b squared is equal to 4, which means b is equal 2 because we take the square root of each of them. So that means this parenthesis turns into y plus 2 times y minus 2. And what happens to that first parenthesis? We bring it down. So we have y minus 5 in the beginning, and this whole thing is our answer. Okay. Let's see. Go ahead and do the next one. Okay, so you're doing the next problem. Okay, maybe take a minute, minute and a half, and then compare with your neighbor. Okay.
It's just like, let's look at notes. The last notes, the last one on the first.
With factoring, do we care about the negative signs? And we just see the number as the number? Or whenever it's like factoring?
For the very first part, like factor by grouping, you have to include those negatives in there.
Oh,
And so like when it's more breaking down, that's when we'll use it as.
Yes. Yes.
that was on notes 6. I'm pretty sure I see. I was here Thursday. Professor Marcos?
Yes.
She's not gonna, never mind, you're not gonna know when it's not here.
Oh, okay.
It's Monday.
Okay. So your first step should have been factor by grouping, which means we group the first 2 terms and then the last 2 terms. And then we take out a GCF. So what GCF did you guys take out of the first one? P squared, which means we're left with P plus 7. Okay, and then what GCF did you take out of the second one? Negative 9. Good, because we wanted what inside the parentheses? The P plus 7, right? We wanted the parentheses to match. We wanted them both to have P plus 7. What's my next step? Good, so I have P plus 7, and then what's in my other parenthesis? P squared minus 9. And then can I simplify this further? Not the first one, but the second one. And I know that the second one, A squared is equal to P squared, which means A is equal to P. Good. And then B squared is equal to 9, which means B is equal to 3. So I bring down my P plus 7, and then what are my other 2 parentheses? Good, P plus 3, P minus 3, and that is my answer. And then remember, of course, if you ever wanted to check your work, you could FOIL 2 parentheses together. Whatever you get from there, FOIL the third one in, and it should bring back to the original equation. Okay. Okay, so now we're going to do something a little bit more challenging, and that is factoring perfect squared trinomials. So what we were doing before is we were factoring perfect square binomials, which means we only had 2 terms, and now we're going to have 3 terms. So in this case, we are able to get something that looks like a plus b squared and a minus b squared. And it's going to determine on what the sign is for that middle term. So notice if the sign is positive, this is going to be a plus b squared. Or if the sign is negative, it's going to be a minus b squared. So it says determine whether the first and third terms are both perfect squares with positive coefficients. So we're first checking the first and third terms are perfect squares and that they're positive. Okay. It says if this is the case, identify A and B and determine if the middle terms are going to equal 2AB or negative 2AB. Okay, so looking at this first example, remember our first step is to look at the first and last term. So we're looking at this term and this term. Can we take the square root of these terms? Yes. And then we look at the middle term. Is the middle term positive or negative? Positive, which means I am going to have 1 parentheses, okay, with a plus in the middle and it being squared. And this first term here is going to be A, and this second term is going to be B. And we do the process the exact same way. So a squared is equal to x squared, which means a is equal to x, and b squared is equal to 49, which means b is equal to 7. So it means my answer is x plus 7 squared. Okay, and again, that was because our middle term was positive. If our middle term was negative, this would be what? X minus 7 squared. So whatever that middle term is determines this sign right here. Positive, positive. Say that one more time. Yes, like we couldn't simplify this further. This would have to. Yes. Okay. Okay, so now we have this next problem. Our first step is to check the first and last term. Can we take the square root of each of those numbers? Yes. Okay, square root of 25 is 5. Square root of 4 is 2. What does this sign tell us? We're going to have a negative in our parentheses. So I'm going to do my parentheses, draw a negative, and then square it. Okay, that's how it's going to be set up. Then I just have to find what a and b is. So a squared is equal to 25y squared, which means a is equal 5y. Good, we take the square root of both. And then I have b squared is equal to 4, which means b is equal 2. So what's going to be in my parentheses? 5y minus 2, and the whole thing is squared.
So we can just use the middle part to identify which kind of parentheses we're going to have?
Correct. Correct.
Good question.
Yes.
Could you, or I'm asking if you can raise it up to where you highlighted the words?
Yes.
I didn't catch that. Thank
Mm-hmm. Yeah, so this is the criteria we're checking for. If the first and third are perfect squares and they're positive. So that not only do they be perfect, they have to be positive. Okay. Okay. So before we do this one, you should be looking at these terms here and asking yourself, can I take the square root of 18 and 32? No, which means I need to take out a what? GCF. So what GCF can I take out from all of them? An 8 won't work. Does 6? I don't think 6 works. 32 doesn't go into 6, I don't think.
Wait, 32?
3?
Is it?
No? 7? No, that's not. 6 is
3? Does 3 work? Someone check that?
Yeah, 3 should be 6.
No, 3 does not work.
No. So it might just be 2. Okay? But what else with that 2?
C squared? C, or C, just C.
Just C, right? Good. So let's take out a 2C and see what's left over. If we notice after we take out that GCF that there's still something that can come out, we can just go back and fix that GCF. Okay, so if we take out a 2C, what's going to be left from 18C cubed? 9C squared. What about from the negative 48C squared D? Negative 24CD. Okay, what about from 32CD squared? What number is going to be? 32 divided by 2? 16. And then we take out the C, so that's gone. So then we have D squared. Okay, now we look at our first and last term. Can we take the square root of 9 and 16? Yes. Okay. So we're going to do the same thing here. We're going to say, okay, A squared is equal to 9C squared, which means A is equal 3C, right? We got to take the square root of the number and the variable. And then B squared is going to be equal to 16D squared, which means B is equal 4D. Okay. Am I going to have a minus or a plus sign in my parentheses? A minus. How do you know? The negative 24CD. So then I'm going to have 3C minus 4D, and the whole thing is squared, and then I have to bring down my GCF. So this whole thing is my answer.
We got the minus because minus 48 C squared D, right?
Correct. Whatever that the middle term was. Yeah, so if that was positive, then we would have 3C plus 4D. Okay.
I have a question.
Yes.
So is it our due diligence on our behalf to figure out what we're doing, which one, by looking at the problem, I guess?
Yes, you would have to know based on
They're all very
everything.
similar, that's all.
Yeah, based on everything you learned, you're going to have to be able to pull it out of your mental toolkit. Okay, I learned that. Let me try this.
Because, well, everything that we've learned right now is tying in from everything previously. So
Yes.
we can basically start from this one right here. Like, okay, well, it's not 3 different partials, right, or whatever.
Mm-hmm.
So we can eliminate this one right here, the factoring purpose, like trinomials,
Correct.
and move on to something below.
Correct. You could also, let's say you forget all these rules and you look at, and this is a bad one to look at. Let me look at, let's look at this one. Okay, Let's say you forget all the rules of these perfect trinomials. We already know how to factor these type of equations. Okay, remember before, and I'll write this down here and you'll see we'll get the same answer. Okay, x squared plus 14x plus 49. Remember when we did the notes prior, our first step was to label A, B, and C?
Yes.
So let's say you only remember this one. You're going to be able to still use this every single time. These are just kind of like shortcuts. Like it's nice if you have them memorized because you don't have to do as much work.
So technically we could multiply A by C, but then you'd be multiplying x squared by
Not x squared. What's A? 1. Right? If we don't see a number, it's 1. So yes, we could do A times C, which is
1
times
49.
49, which is 49. And we need two numbers that multiply to 49 but add to 14, which is 7 times 7 gives us 49, and 7 plus 7 gives us 14. So it would be not quite. So remember, we expand the middle term. So x squared plus 7x plus 7x plus 49. Remember what we did on Thursday?
Yes.
Okay, then we do factor by grouping, and we take out a GCF. What's the GCF of the first one?
The first one is x.
X, so we're left with x plus 7. And what's the GCF of the next one? 7, and we're left with x plus 7, which means we have x plus 7 times x plus 7, which is the same thing as saying x plus 7 squared. And that's what we got originally.
Oh my God.
It's the same. They're all connected. Everything's connected.
That's what was throwing me off, because I was like, I could basically do the same thing with last week's notes, you know?
Yes, but then think of this. Okay, let's say you're taking a time test. Would you rather do this 100 times, or would you rather do this 100 times?
I would do that.
It comes to preference, right? If you know everything, it's easier to solve the problems, okay? But if you remember just the basics, you will be able to solve all these factoring type problems. You will. It will just take you more steps.
Interesting. That could be tricky, I guess. That could be very. You could use that to your advantage. People could write x plus 7 and then x plus 7 again and think that's the answer, but not knowing that it's x plus 7 squared. That's how you want it.
But I would count both correct.
Okay.
I would say this is correct or this is correct. They're both.
Okay.
They're both correct. It just depends on which way you did it. So if you did it this way, I know you probably used the shortcut. If you did it this way, then you see the long way. And plus, of course, you're showing all your work on your test, so I can see what method you're choosing. Okay.
So there's no way there's no right answer on how to do it as long as you solve it correctly.
Honestly, when I look at these problems, it takes me a minute to think, okay, what method makes it easier in my head.
Okay.
And then if I can't remember a way, then I know I come to this. Always come back to this. You're going to do a lot of this in college algebra. That's their favorite method, factor by grouping. Okay. So let's see, we have one more. Go ahead and try this one. Take a few minutes and then share with the neighbor. So your very first thought should be, okay, let's look at my first and third terms. Can I take the square root of 5 and 45? No. Okay, we can't take the square root of 5. No, that's going to be a decimal. And you can test it on your calculator. Use it square root of 5, you'll get a decimal. Square root of 45, you'll get a decimal. That tells you you can't take the square root of it. Okay? So then from here, since you can't take the perfect square roots of these, then you know you have to take out a GCF. And what GCF did you guys pick or take out? 5. So then we're left with W squared plus 10W plus what number? 9. Good. Then we look at this again. We have W squared and 9. Can you take the square root of these? Yes, so then I'm going to go ahead and assign A squared to W squared, which means A is equal to W. And then B squared to 9, which means B is equal to 3. So I have 5, because I'm going to bring down my GCF. And I have W
plus 3 squared.
Good, and how did I know it was plus 3 squared and not minus 3 squared? Good. This positive value here tells us it's a positive value there. So that's my answer. Okay.